Hello everyone, welcome to today's webinar, Perfect Packaging Design driven by MODSIM. I am Anna Liang and I'm a modeling and simulation industry process consultant at Dassault Systems. Here's today's agenda. We will first see how MODSIM drives perfect package development. Then we'll talk about how you can design perfect CPG package with MODSIM approach and how MODSIM can be further integrated in the product development process. First, let's take a look of the recent trends and challenges on the CPG industry. I don't want to go into too much details, but it is not surprising that sustainability is one of them, if not the most important one in recent years. Requirements for sustainability are increasing at every single step of the value chain, from sustainability of the material being used, the optimization of the design so that you're using less material, the distribution channel, to the end-of-life disposal and material recovery. It really covers everything. And it is very clear that a much higher level of innovation and agility will be required to deal with the pressure and potential disruptions emanating from these trends. So how does MODSIM fit with these trends and challenges? This can be done by automation, integration, and democratization, which the 3D Experience platform has a really nice functionality that helps to meet the challenges we just talked about. Let's start with automation. The platform provides end-to-end automated simulation opportunities and can orchestrate the automation of repetitive and complex tasks. As for the integration, the 3D Experience platform can integrate all simulations and functions in one place. That means if you're a CAE user or if you're a simulation expert, you can work in the same environment as designers, product developers, and project managers. Project plans, results, and issues can be shared with the colleagues and worked on platform in a collaborative fashion. 3D Experience platform also comes with a really nice set of tools to make this automated workflow reusable, so that we're capturing the best practice in the industry. In this way, non-experts like packaging designers and project managers can access these workflows. The user experience also are relatively simple and elegant and efficient because it's all in the same database. So we've been talking about MODSIM in the past couple of slides, and many of you probably have heard the term multiple times in the past. But I do want to take this time to kind of re-emphasize on our understanding as Dassault Systems on the terminology MODSIM. So what exactly is it? There are a lot of ways to define it, but to keep it very short and simple, MODSIM unifies modeling and simulation on a common data model within a single user experience on the 3D Experience platform. By breaking the silos between CAD design and numerical simulation, including structural simulation, fluid simulation, electromagnetic, and many others, it allows a deeper integration of simulation into business processes. And we're enabling non-experts to use the simulation to support their packaging development activities. Everything can be done in a web browser, which unlocks a lot of opportunities. We will get into more details in the next couple of slides. Now let's look at how MODSIM approach really makes a difference. Here on the left, we're showing more of a traditional workflow, where things happen in a linear way. We will normally start with the CAD design, and before running the simulation or applying anything, we'll first need to do geometric cleanup, and potentially that's already another tool. And then we'll apply meshing, simulation setup, and then solve it. We will look at the results and be like, okay, I'm happy or I'm not happy with the results, so I'm going to do an iteration or multiple rounds of iterations. That means we're going to change the original CAD design. Now, that means we have to re-walk this process again and again. It involves not only multiple files, but also multiple people. As you can imagine, there would be many file transferring, email exchanging, and potentially things got put into PowerPoints or reports or things like that. Probably not the most efficient way for packaging design. In comparison to that, on the right-hand side, we have the MODSIM approach. MODSIM approach uses data objects instead of files, and these objects are connected in a common data model and can communicate with each other. In this way, we'll have a full associativity of the data, with easy and quick updates of all models in different physics, which leads to a fast iteration to better support design evaluation and decision making. Let's take a deeper dive of the MODSIM process. So a design loop still contains the things that we saw in the last page. So CAD building and select mesh, simulation, run, evaluation, and model update if you want to change anything there. But the way the data is organized here is not based on files anymore. We have the data objects in our common data model. We will still start with a CAD model, potentially with an assembly or just a single part depending on the object itself. We can then do geometric cleanup, which this geometry will be linked directly to the original CAD. We'll apply mesh, apply any connections that is necessary, and then do the simulation setup. Again, everything is connected, so although it seems like we're applying the simulation directly on the already cleaned geometry, we're still linking it back to the original design. After the setup, we'll be able to run the simulation and then look at the results and decide what to do next. Now, what if you want to change the design a bit and run the simulation again? With all the data objects being part of the database, design iteration is very simple. All you need to do is to modify the CAD data and run with one mouse click. Everything, all the downstream activities will be automatically updated. We're having the full associativity here. You can just rerun the simulation and there you go, it's done. And this is not limited to only one type of simulation or one type of physics. Automatic updates of all models for different physics can be run, and it can be all done in a single user environment. So MODSIM helps to streamline data exchanges significantly and break down any silos between design and simulation. It can also help us to address a challenge which is perhaps a little bit more specific to CPG industry. Comparing with transportation and mobility companies or aerospace and defense organizations, where simulation is a very well-known and well-established tool that has been used for decades in those industries. There are lots of simulation experts in the company. Versus in CPG industry, many potential users that will benefit a lot from running simulation may or may not have the expertise. This means that automation, integration, and democratization through a web user experience that is simple and efficient is really the key here. Democratization of simulation puts the full potential and power of today's advanced simulation tools into the hands of non-experts. In this way, we can boost innovation and allow more design alternatives to be explored safely, quickly, and at a lower cost. It also allows the experts to focus on more complicated tasks. And I would like to show you how this web-based user interface looks like. Let's look at this example. A designer can come into this web browser and drag and drop the predefined simulation template created either by us or by simulation experts at the company. All these things can be customized to the needs. You can change the title, drag and drop new geometries, have some user input. Here we're taking an example as the flow rate. And then you can save this process and then execute it. Everything can be done on this web browser. After the simulation is successfully completed, the user can then drag and drop to see the results again in a web browser. And as you can imagine, the role of the simulation expert is changing from one that focused on the actual running of the simulations to the one that is more focused on capturing their knowledge and expertise in a form that is safely and robustly reusable by those in their organizations who are not experts in the underlying CAD and simulation tools. With that in mind, let's look at how this capability helps to design a perfect package. Simulation can be used to support decision-making throughout the value chain in CPG. Let's look at the very first thing on the left-hand side. We will start with the virtual material models. And then we can simulate the manufacturing process where the packaging components are created. Then there are simulation scenarios focusing on high-speed dynamic factory environment, such as capping, conveying, labeling, filling, end of line, and things like that. Then additional analysis, which are related to the distribution of the final products, can also be simulated. Things like palletization and just transportation simulation. Lastly, the consumer experience and end-of-life activities can also be simulated. Things including how might a bottle appear on the shelf, how much force do I need to open the packaging and dispense the product, or can my packaging be easily separated into different recycling streams, for example. All of these can be modeled and simulated, and it can be done for every new bottle and packaging design.
How long does it take to develop a new bottle? Several months? If so, would you believe us if we tell you it can be done in few weeks? A typical development process involves designing, simulating, prototyping, and testing. All done by different teams, often working in silos. Thanks to the 3D Experience platform, the collaboration between teams is seamless. And leveraging an integrated modeling and simulation solution, it is possible to develop a new approach that can drastically reduce the development cycle. This can be done by replacing physical prototyping and testing with a virtual twin, and democratizing simulation. Using design parametrization with automated processes, different bottle designs can be generated and validated rapidly to meet consumer experience, shock resistance, and weight target. This improved development cycle is essential to achieve new sustainability targets, with a reduction of 20% in plastic usage, while maintaining a high-quality product. All of this with a faster turnaround time, going from 10 months to 3 weeks.
Remember we talked about the trends and challenges in the CPG industry? Of course, all companies today have their sustainability targets. For example, manufacturers need to reduce the weight of the plastic bottles so that they're reducing the total material being used in each design. A manufacturing plant that produces 10 million such bottles by reducing the weight of just one bottle by 20% would lead to a saving of 100 tons of material. And you can imagine what it means for companies producing many different ranges and sizes of different types of bottles. Now let's look at an example that focuses on the performance of the cap. Here we picked 3 of the most common simulation scenarios which are performed in the CPG industry, including lid opening, cap application and removal, and a bottle drop test, with measurable performance targets for each requirement. For example, for the drop test, we have to ensure that the bottle survives the drop without the cap and the bottle separating, and the cap opening or the sealing surfaces being compromised. So, there are a number of risks involved in this particular design. Now let's take a look on how it looks like in the 3D Experience platform. All of these simulations are built here. We are using this bottle on the platform. Zooming into the cap, on the left-hand side we see the CAD, and right-hand side we see the mesh. Here we're modifying the geometry just a little bit, and as you can see with the full associativity on the platform, things got automatically updated. Same for the simulation scenario. And here we're seeing the cap application and removal simulation. The reaction forces and displacement curve can be plotted. We can now check the drop test as well. The bottle is filled with fluid, so we need to make sure that the cap doesn't open when the bottle is dropped. So this is actually an interesting trade-off exercise. We want the pack to be easy to open for the consumer, but also robust enough to survive the supply chain. A MODSIM approach can really help the development team here to quickly explore many options and really understand the design sensitivity and ultimately arrive at a design solution which can satisfy all requirements. So how does democratization work? Let's look at the as-is scenario first. And this is how many of us still work currently, where the designers develop the CAD and then hands over to simulation engineer who is performing the simulations. Now, since this is done for every single design iteration, you may want to start to democratize that process. You don't want to go over and over again through the process from scratch, but this is still often the case. The platform actually provides the perfect environment to democratize all of these workflows. This process will change for our customer using 3D Experience platform. What we also see from our customers is that the roles are starting to evolve, which is interesting. So previously, those who has been simulation specialists start to become method developers. They are creating these automated methods within the 3D Experience platform, which creates the opportunities for democratization. The tools will then be handed over to the designer. Now they will be able to execute the simulation all by themselves. They're designing the model and running all the simulations in one go. And as a consequence, the time to create a new model, optimize it, and validate it is significantly reduced. In this way, the designers are way less dependent on the simulation experts because they can evaluate their design by themselves whenever there's a new iteration or small changes comes up, and they would be able to understand what the simulation tells them and make data-driven and simulation-driven decisions for next iterations. To enable democratization, we require 3 things. The first is the engineering template. With these, you can automate any kind of reoccurring analysis so that you can automatically create a simulation object where you define everything, including boundary conditions, material, things like that, that is required to run the simulation. We'll also need Process Composer on the 3D Experience platform to create a process where we design the sequence of activities and integrate functionality on the platform. For example, in this process for the bottle simulation, you have the instantiation of the engineering template, the different simulations, and report all of the outputs that's coming directly from the simulation into the GUI. You will also need a GUI builder, where if you have the process ready, the GUI can be built in just a few minutes. You can simply drag and drop your different icons on the GUI and you quickly have the interface ready for the designer. So that's actually what a method developer is using. They're using all these techniques and tools to build the automation on the 3D Experience platform. After the methods developer has created a method, or we can call it a template, this is the outcome: a graphical user interface seen in the web environment of the 3D Experience platform. This is an environment that the designers would use. They would create the bottle in the usual way and then simply drag and drop it into this web interface. They can set the values for the geometry parameters if those values were exposed to the user, select the load case and run the simulation. They can also change the material and many other things in the simulation setting. The results are automatically fed back to the environment, so the designers doesn't have to start the design and simulation apps at all. They get all this information from a single web interface. So we use the bottle capping design as an example, but really this type of workflow, building the simulation template and putting the GUI, applies to many other simulations in the CPG industry. Using traditional iterative process to change the geometry or do a trade-off study based on physical test results can be a really, really long process. And it can easily take several months to resolve a sensitive design trade-off problem. MODSIM really helps to significantly accelerate this process. Now let's move on to the third section of today's webinar. How does the MODSIM integration look like? So I would like to quickly explain the different layers of this 3D Experience MODSIM graphic and how they relate to a typical product design process. So here in the center, we see the MODSIM core. This is where we find all of our typical information related to our end-to-end simulation. The CAD, which is the model, the simulation, and the results for the design space of our models. But the modeling and simulation isn't used in isolation. It's typically part of the broader activity like an innovation project or cost-saving project. So in this diagram, we can see that there are different layers of activities and information that surrounds the core MODSIM capability. So we have the project management layer where we track and manage project tasks, timelines, resources for the complete program. Then we have the product management layer where we capture the product design and performance requirements and manage design changes. We have MODSIM at the center where we perform product design, modeling and simulation, performance evaluation and trade-offs, and design explorations. And finally, we want to be able to analyze results, make collaborative decisions, and manage design changes. So let's put what we've seen in the context of the CAP design. We have seen how the MODSIM core works and how it is being democratized. In the core, we have model and simulation, which is the MODSIM, and then we have templates and process automation to create a web-based user interface. This platform capability is the key for democratization, which is essential for the CPG industry. Democratization gives simulation in a standardized way into the hands of all designers or product developers in the organization. Everybody can now execute specific simulations and use them as a base to take better qualified decisions, which have a business impact, and in case of CPG, can have a huge environmental impact as well. But what's even better, what we have seen now can be deeper integrated into other layers as well. So for our CAP project, we can have a project timeline with tasks and activities assigned to the team members. We have clearly defined requirements which described what the CAP is required to do in terms of functional performance, including lid opening, capping and uncapping, and drop test, the 3 simulations that we looked at before. These then help to identify technical risks and drive the MODSIM program at the core of the process. Let's look at another example, which is a plastic bottle lightweighting project. With clearly defined design requirements, optimization of the design can take place. And this type of optimization is made possible because the methods developer has previously built and tested automated processes and simplified the user interface that's being deployed to the lightweighting team, who are mainly designers. And finally, the results are generated for the team to analyze and review to make final decisions. So MODSIM approach is efficiently generating the data and results that will help the team to make well-informed decisions on the final design that will be recommended to the stakeholders. We will see in the next video an example of how a democratized simulation process looks like, and this is the kind of process that might be accessed and used by someone who's not necessarily a simulation expert. In this dashboard or this simulation template, the user can simply drag and drop the geometry that they want to test on. They can also view this base geometry in this 3D Play web widget. They will then select the material of the bottle as well as the thickness distribution file that has been previously uploaded to the database. other user input, including the top load target force and the squeeze target force. And this simulation process can be simply started by clicking the Run button. After simulation is being completed, we can now view the results of this optimization process. The designers can come in and check the results for each iteration. Values such as optimized mass as well as the percentage change in mass comparing with the baseline simulation or baseline design are reported directly onto this web widget. Other predefined values such as average section thickness distribution and many others can be loaded onto the dashboard as well. It is a pretty straightforward process for the designers to perform an optimization study on a certain design. Now, if we go back to this diagram, it's pretty clear that MODSIM loops efficiently generating new data and revisions of data as design processes. We don't really need to do file exchanges or email exchanges anymore. We also don't need to have any reports in PowerPoints or Words document, nothing at all. It all happens on one single platform. Now, as you can imagine, there are many different products in the CPG industry. All of them go through the development process from concept, detailed design, production, transportation, use and disposal, this whole loop. So we will run thousands of MODSIM loops, each of them bringing efficiency savings. To sum it up, if you add up all these efficiency savings together, this is where you get incredible, tremendous value. This concept, we call it left shifting. All of these savings adds up so you can bring your whole project plan forward. We can save an enormous amount of time, of money, and this is where the real value of MODSIM can add up in really something quite incredible. This gives the necessary agility to CPG customers to develop competitive and sustainable packaging solutions in a shorter period of time. And let's talk about what benefits does the MODSIM approach bring specifically to the CPG industry. We talked about how sustainability is one of the main goals and targets for CPG companies. Therefore, CPG industry needs agile development processes and can exploit the use of simulation to reach a higher level of innovation within a short period of time. We all know simulation is the key for innovation. The more simulation, the more innovative. How can the usage of simulation be increased is the question. By transferring simulation from the hands of a few specialists into the hands of the designers, using automated simulation processes that can be executed as a standard tool by any designers or packaging managers on any device in their daily work is the key. We call that democratization. This unlocks a lot of potential and opportunities. This also helps to standardize simulation processes and test procedures, so all necessary steps are always included in the design process and not forgotten by accident. MODSIM also maximizes the benefits of simulation because things are all tested virtually. You can test different materials, shapes, sizes, components easily, and you can explore and optimize your design fairly quickly. Identify the critical design parameters, study the impact of variations in geometry and in material behavior due to process parameters. All these helps to avoid or reduce risks and make sure that the designs really work. MODSIM approach also helps the designer to easily adapt requirements based on feedback from production or consumer experience and check designs against them. To summarize, the left shifting in the development process leads to efficiency gains in which results in both save time and money and also speed up of time to market for new packaging designs. By doing so, the companies will be able to minimize existing materials and understand the behavior of new materials and new sustainable alternatives, or use recycled materials, and they have a higher chance of reaching their sustainability targets. And this is really the results that we see. First of all, the typical simulation experts will now become methods developers, and their knowledge and their best practices are being well captured in the simulation templates and the processes that they created. So if you want to reach your sustainability targets in a short time for all different types of bottles you're designing, now instead of relying on those 10 simulation experts that you have in-house, now you have 200 users. And these 200 users can run sophisticated simulations because they have been democratized. Certain KPIs, such as mass reduction, can be achieved in a more efficient way as well. And we can significantly reduce the overall development time for every single bottle. And we can significantly reduce the overall development time for each packaging design. Now let's look at some key takeaways. The 3D Experience platform unifies modeling and simulation in a single user interface. Automation and democratization of simulation improve collaboration and avoid silos. It can be deeply integrated into other layers of activities and company processes as well. All the efficiency savings result in a left shifting, which means much more agility in development processes. And the concept of the MODSIM approach can be applied to many different industries. That would conclude our webinar today. Thank you all for attending.
Thank you very much for that excellent presentation, Anna. At this point, we will proceed into the Q&A portion of the program. Those in the audience, if you have not already, please click on the Q&A tab to the right, type in your question, and click Submit. We've received a lot of great questions, so let's dive right in. What CAD geometry does the MODSIM work with, and can we use non-DS CAD on the platform?
Thanks, John. So on the platform, we have our native CAD tools that is based on our CATIA. So if you're familiar with CATIA, you're going to find the user experience, user interface very familiar. We also have SolidWorks, and we have a pretty good connector from SolidWorks to the platform. And as I was mentioning in the presentation, the full associativity as well as the automatic update still exists when you're using SolidWorks. It does not work as well, I have to say, as if you were to use the native CAD. As for the non-DS CAD, in a similar fashion, we have the connectors, but still there is the value definitely can be realized. And I would say there's more value if you're using the native CAD.
Okay, thanks. Let's see what else we have here. Is there any difference between the simulation capabilities on the platform and the standalone tools?
All right, so for the standalone tools, I believe many of you are familiar with our Abacus, which is our finite element analysis tool for structural analysis. A great nonlinear simulation capability. We also have electromagnetic tools, CST, and things like PowerFlow and XFlow, which are our CFD tools. So all these, so Abacus has been kind of taking the essence of it and brought to the platform quite well. So the solver, again, is very similar. The options are very similar. I would say it is more user friendly if you know how kind of the Abacus CAE user interface is. As for the CST, which is electromagnetic, as well as the CFD tools, we have a capability called Power By, which we're linking those standalone tools to the platform in a way that you can still call the standalone tools. There are also other capabilities like Eyesight, which has been rebranded to the platform. Many of the capabilities are in Process Composer. So if you have any specific question, please feel free to reach me. Yeah, we can take a deeper dive on the specific simulation workflows that you're interested in.
Okay, great. Let's see. Will Dassault build the democratized simulation workflow, or do we need to have the simulation case ready?
In that sense, actually, both would work. So we've definitely, started with customer who already have their simulation workflow, and we'll come in a kind of do a service type of work and democratize that specific workflow. Building the template, building the GUI, so that the tools will be put into the hands of non-simulation experts. However, we also engage with our customer in a way that if you just have the physical testing or you have an idea of what's physical workflow that you want to first create a simulation case and then democratize it, we're happy to help as well.
Perfect. I think we probably have time for one more. So how about, does Dassault have LCA tools?
Yes, we do. It is a whole other topic. LCA is one of the main focuses for many CPG companies these days, and we do have a really good library, and then we have a pretty powerful tool as well. Again, this kind of links to the everything on one, everything in one place. LCA works really well if you have the CAD, have the simulation, have all your design PLM system all on the platform, although we do recognize that that may or may not be the case. Anyway, so if we do have a pretty powerful LCA tool. So if you're, again, interested in that, please reach out directly to me, and I can share more information on that.
Okay. Well, we are just about out of time. Again, thank you, Anna, and also thank you to our sponsors at Dassault Systems. But mostly thanks to all of you in the audience for your participation today. Finally, for those of you who have asked, you can find materials from today's event and all Packaging World webinars archived at www.packworld.com/webinars. Also, if you enjoyed today's presentation, please take a moment to fill out our post-event survey, which is now live to the right of your screen. Your feedback is very important to us and will help improve our future webinars. Thanks once more to our attendees around the world. We'll see you all back here Tuesday, October 15th at 1 p.m. Eastern, 10 a.m. Pacific for our next Packaging World webinar, Smart Packaging Trends, Digital Passports, and Digital Watermarks. Have a great day.